everyone, and welcome back to day 2 of our training webcast. This is Danielle here again with Kate Fontanella, our trainer, and Ron Cormier to help out with questions from our professional services team. And I'll hand it over to Kate to get started, but just a reminder, you'll log back in using the same link as you used today and yesterday to join us tomorrow again at 11 o'clock Eastern Time, and we look forward to joining you then.
Hi, everyone, and welcome back. Today we are going to continue on with our series, excuse me, and we are going to start off with working with semi-structured data today. And what we're really talking about are really 2 new features that have been added to Vertica. The first one is flex tables, which we are going to talk about, which allow you to bring semi-structured data into Vertica. And what you want to understand is this is going to be sold as a separate product. All databases will come with 1 terabyte of data for flex tables, but then if you would like more, you would have to purchase a second license. So we will be talking about that as we move forward. And then the other piece is the age catalog, and this is really for users that already have Hadoop and Hive databases. It's really just a connector that's going to allow you to work with the age catalog of Hive and bring in some of the information into Vertica and use the power of the Vertica analytics with your Hive system. So we're going to talk about that today. We are going to start off with flex tables. And in this section on flex tables, we're going to talk about working with the semi-structured data and how to create those flex tables. Once you create a flex table, the idea is that you can quickly load the data, and this data could be things like social media. It could also be log files, eliminated files, and other information that's not typically considered ready for Vertica databases. So previously, when you were working with this, this type of data required some significant prep to get it into Vertica, but now you can bring it into flex tables and just a few steps, and then the data is ready to be queried through Vertica. So I have to admit, I borrowed this graphic from one of the engineers that was first teaching this, and the reason I liked it so much is because the idea is that you really are tossing the data into Vertica, and it really is going to be almost that simple. So the idea is to take the idea is to take the flex tables and use their associated helpers, map the functions, and general integration into the HP Vertica so that you can create and manage your flex tables. So the idea would be is that flex tables aren't going to require schema definitions. You don't need to do column definitions. You full Unicode support and full support of the SQL queries. So once you create these flex tables, you load the data in, you're able to start querying it and using the benefits of the Vertica analytics tool. So just to talk a little bit about what is the change. So prior to flex tables, you really had to take in this example that we're going to use today, I'm going to take you through using some JSON files and using some Twitter data that you're going to bring in. So prior to 7.0, you basically had to download the JSON file from the web, convert those files into delimited formatting using an ETL tool. And these would be the commands that you would use. So you'd create your table, and then you would set up that it's going to be text, what kind of data type, language, varchar. Then you'd copy the data from the delimited file that you've already prepped, and then you could start querying. The idea with flex tables is now you create a flex table with or without column definitions, and we will talk about that in just a few minutes. You load the text JSON data using the flex table parser. In this case, we're talking about JSON data. It can also be delimited data. This parser would be the FJSON parser, and we'll talk about both of those in just a few minutes. And then query any values you know in your data. So you can find out that information from using some of the map functions, which we're going to talk about as well. So really, you can see from this process, these would be the steps that you would use or the commands. So you basically create the flex table. Then you copy the data from the web, the JSON data, and then you, using the parser. and then you can actually just start querying the data. So you can actually pull the data from the Twitter site, and now this would be the result of pulling that JSON, that Twitter data, using the JSON parser. So you would end up seeing the columns that are really part of the data that was already part of the Twitter information. So you'd have your user language, your user location, and where the user created the information. So this is the idea of flex tables, is it's meant to be much simpler, and you're able to have access to it right away. The flex table parsers that you would use, two of them are coming out of the box. The F-delimited parser, that's used to load delimited data regardless of the source file, column ordering, or existence. And then the F-JSON parser is able to load JSON data, including handling nested structures. So the idea is they're both designed to let you to let the data in whenever possible, and there's some optional controls over your rejection. So the parsers are out there, and Ron, correct me if I'm wrong, I believe that those are the two that are coming out of the box, but there are also some others that are in development, or is that what, I believe that's what the engineers were saying.
Yeah, that's exactly right. These are the two that are shipped with version 7, but we expect to have more in the future.
So definitely keep an eye out for that. So what happens when you create these unstructured tables? So what's going to happen is you're going to create your flex table, and when you bring in the data, it's going to create two basic columns. There's going to be the raw data, which is all of the data in one column, and then there'll be an identity column. This just allows you to understand where the different rows are within the data. And then you have an associated keys table, which is the flex table keys table. And then you also, it creates a default view for the main table called the flex table view. So these are the three things that are going to be created. The really important piece is understanding the two items here, the raw and the identity. This raw data is really what you're bringing in. You're bringing in the data and you're bringing it into one column into Vertica. The idea is that if you know something about this, you can start querying it right away. But what we're going to look at is how this would look if you also decided that you wanted to define some of that data and materialize it. And the idea of doing some materialization is it's going to make your analytic queries run a little bit better and more like Vertica-like. There's still going to be some details that you have to understand in terms of that is still going to take some more resources and so forth. But the idea is that this is kind of what your flex table data would look like when you first bring it in. You bring it in and you've got some column designations within the data, but the A, B, C, and D are really all in one column. So what you can do is you can then define the columns that you feel like you might use. So in this case, we're saying that we're going to define columns A and C, and then your raw data column still exists. So if you needed to do any kind of query against B and D at any point, that data is still in the system, but the columns A and C are now materialized, and you can actually use them in your regular analytic type queries and really point to those in your DDLs and so forth. So in terms of querying, the idea is that you can directly query from the flex table. So if you just had this initial view of all of your columns in one column, you could actually query that right away. You can do a direct query. What we're saying, though, is that you can really do two things. You can create that view where you've got your columns A and C defined, or you can also use these helper functions, compute flex table keys or compute flex table keys and build view, and that would actually create a view for you that you could use to then query the data. So you can really go directly to it. You can use the helper functions to help define that view, or you could actually define your columns yourself. So you can do the materialization yourself. The idea would be is to then run the queries in this second case right against those views, and you're going to get some of the analytics and the benefits of the Vertica query system. So that's really how that's set up to function. And Ron, do you have anything else to add to that?
That sort of process.
Well, yeah, a little bit. Maybe just giving a different perspective on it. The idea behind flex tables is to make data exploration much easier. So Kate showed a screen which had a few different queries. We created a table, we loaded the table, and then we read from it. And that's sort of the old way of doing it, and that's still valid, of course. But what typically happens in the real world is there's a lot of rejected data, because especially the first time when we do a data load, because we don't have our types set up properly, our data types. We don't have the correct number of types. We don't know what the data actually looks like. We have to make some guesses, and then we do a load, and we see a lot of rejected data, and then we change our structure, and then we do another load, and it's an iterative sort of thing, which can be quite time-consuming. The idea behind flex tables is to really eliminate that iterative process, and so that the first time that you load data, all the data will load. You just need to tell Vertica what parser to use. And from there, once you have all the data loaded, you can then explore the data to determine the appropriate types and do analysis if you want to. In terms of what's happening under the hood is when we load data into an unstructured table, we really just have one column. Am I getting ahead of myself, Kate?
No, we just talked about the one column. Yep.
So yeah, you really just have one big column. It's like a var binary. It's a big blob.
So it's kind of like, this is a nice structured way of looking at it. Sort of.
Sure. So when we just create a table and we create an unstructured table or a flex table and we load data to it, it's just a big blob for each row. And what Vertica does is, since it's this special type of table, if we try to select a column from this table, it does a lookup into that blob. It's called map data. So we look up into the map for the values of the keys that we're looking for, the columns essentially. And if the column doesn't exist, flex tables are special because they don't, it won't give you an error saying column doesn't exist. It'll just return a null value. So if the column does exist, it extracts that data and returns it. So so really, it's just under the hood, it's just a special type of column that we can read from. And in terms of performance, you're not going to see the type of performance that you'd see from a normal Vertica column, because it has to do this lookup and this extraction from the blob for every row. So in order to improve performance, you can create normal Vertica columns in an unstructured table. So normal columns are just where we extract data from the blob and have it be its own column. And we're a column store, so that's really easy to do. And when we've extracted data from the normal columns, selecting those normal columns is really fast. We get the normal Vertica performance from our ROS containers. So that's how we get performance, and you can have these hybrid columns in the same unstructured table, like Kate is mentioning.
So again, just to sort of go back to this diagram, if you're defining those columns A and C, you still have B and D as part of the raw data column. So it still exists. It's just that now A and C are going to function more like real Vertica columns. You're going to get the performance that you're looking for from Vertica. So,
right. So
that's really one of the ways to really go with this.
Yep. And one of the nice things about these real data columns is that when you add more data, these more unstructured data to your blob, these real columns get populated automatically. So subsequent loads will populate the real columns automatically.
Okay. Thanks, John. So, sorry, I'm just going to jump ahead now. Just to point out some new configuration parameters that you should be aware of. First of all, in the vCatalog table, if you do have a flex table that's been created, you're going to see a field that's called is flex table, and that would be set to true. So if you're creating one, you should know that. There's also this flex table raw size, and that's the default starting size of the internal raw map column. So remember I said that you get two columns. You get the raw and the identity when you first load this data, and the flex table raw size is going to default to 130 bytes, and that's something that you could change. And you should be aware that that one can, sorry, that column can go as big as 32 megabytes. Was that right?
I was just going to look that up.
Yes, I believe I wrote it down, and then it can go as big as, yes, 32 megabytes. So, again, if you're going to change that size, obviously you want to think about that. That's pretty big, and especially if you're not defining columns after the raw data column, obviously you're going to be querying against that really large size. So just kind of keep that in mind. The other one to keep in mind is the flex table data type guess multiplier. And this is just talking about the fudge factor for how much space the flex table views allot for string fields. So again, these are some of the parameters that are new coming in with flex tables, and things that you want to just sort of think about, things that you might need to change, but again, you're probably new to this concept of flex tables, so you probably want to leave things at the defaults and then determine whether you need to change the defaults. These have been set with some definite thought processes. So again, these are the defaults. You may want to change them, but you might want to work a little bit with them before you start changing any of the default parameters. And the other thing to just keep in mind is the second one, the flex table data type guess multiplier. I love the name of this because it's really nice and long. This one is the size of that initial column. Once you define your real columns within Vertica, so if you define those columns A, C, those are going to take on the width of a typical Vertica column. So like if you set something to varchar as your data type for that column, it's going to be a width of 80, and that's kind of just default. So keep in mind that this is just for that initial data load raw data column that you're bringing in, that's what these are set up for. Okay.
So let me just chime in on a couple of questions here. A few questions about the parser and how data is extracted from the blob, from the raw bar binary. And the key here is that anytime you load unstructured data, you need to tell us the delimiter. That's the most important thing that the parser does. It puts the data, it finds out where the delimiters are, and it creates a map. So we have two parsers right now that delimit based on JSON, XML, and delimited, and that means like pipe delimited, common delimited, whatever, tab delimited. You can tell it what delimiter to use. And so once we've got the data in the map, we know where to look for the different values given a key. And that is what happens at execution time when we run a select statement. So if we're only interested in finding a column called user.name, we go to the map and we know where that value is stored in the map. We look that up, and that's what we return.
Okay, great. So the other thing that I was saying is that in terms of licensing, this is going to be a separate product license for Vertica. All databases, if you upgrade to 7.0, you're going to start with 1 terabyte in a typical Vertica database. The idea here is to give you a chance to try out using flex tables, see if this is something that's going to be useful to you. But more than likely, 1 terabyte is not going to be a lot for semi-structured data. So you're probably going to need more if you really are going to start bringing this tool in and start using it. But you do start with 1 terabyte, and then if you want to go bigger than that, it would be a separate license. So just be aware of that this is a separate product. So that really takes us through flex tables. And the next thing that we're going to talk about is the H catalog. And this is really the idea of Vertica working along with Hive. So the idea is that you've got your big data lake from Hive, and Vertica is, with the H catalog connector, the idea is it's pointing to the H catalog in Hive, and it's going to allow you to combine your structured data from Vertica with your unstructured from Hive, So the idea would be is that if you've already put in the work of taking your Hadoop data, putting it into a Hive system, you now can use the tools of Hive and connect it to your Vertica database. So this is really what we're talking about here. So previously, when we were in Vertica 6, you were able to explore the lake or the big data lake kind of more one rock at a time. But now Vertica external tables can query the Hadoop data. And basically Vertica could use the external tables, query the Hadoop data using the HDFS connector. And again, that's not going away. It's just that we've made this connection a little bit more streamlined. So the idea would be that Vertica 7 is more like you can use the chart. You can have Vertica external schemas mapped to Hadoop, and then the H catalog knows the layout of your Hadoop data, and you're able to connect to it a little bit better. And I know that Ron probably has a few things to say about this, because in our first discussion, he was saying, well, it's not quite that simple, because, of course, the Hive stuff isn't easy to put together. But the idea would be is that you're already a customer who's already set up some Hive, and this is what you would use the H catalog for, is to connect to that information that you've already built.
Right. What we're trying to do here is make Vertica the primary interface that you use for your big data exploration. And in a sense, there's still, if you've already done some exploration in HDFS and you've applied some structure with Hive, then we can just take advantage of that and leverage that and connect to Hive and use the H catalog data to access your data.
Okay, great. So what is really the difference between the HDFS connector and the H catalog integration? So really, the HDFS connector, you add structured to unstructured data by defining a schema through Vertica external tables. And of course, we're still going to support that functionality. So if you've been using that, you're happy with it, it's still out there. The H catalog is more of an integration for users that have defined schemas for their Hadoop data using Hive. So it allows them to reference the schema in Vertica and then analyze the Hadoop data. So that's really kind of the difference between the 6 versus the 7, the H catalog versus the HDFS connector. So a couple of things that you need to be aware of. If you are going to use this, you need to have the following things running before linking to the H catalog schema to Vertica. So we're talking about obviously having HDFS running, your Hive server, your H catalog server, which is WebHCat, your H catalog source, and your Java virtual machine needs to be installed. So these are the things that you need to think about before you start making these connections for the system. The idea behind this is that you're going to get a unified analysis. So this would be for analysts who want to review structured data with less structured data and kind of use Vertica side by side with Hive. So the example might be a marketing manager who wants to take customer comments about a product, maybe from a solicited survey, and then maybe some unsolicited information like from Twitter that they've captured into Hadoop and built into a Hive schema. So the idea is you want to kind of combine these two things that you've been collecting and do some analysis against them. So this would be kind of what we're looking at to do with this. So we're going to get a little bit into this sort of data processing. The idea here is that you've got the Apache Hive that lets you query the data stored in Hadoop distributed file system the same way you'd query data stored in a relational database. You've got the Apache H catalog, which is the component in Hadoop ecosystem that makes Hive metadata available to other Hadoop components. And then you have the WebCat that makes the H catalog and the Hive data available via the rest of the web API. So through it, you can make the HTTP request to retrieve data stored in Hive, as well as the information about the Hive schema. And what we're doing is HP Vertica's H catalog connector lets you access access that data available through the web HCAT. So you use the connector to define the schema in the HP Vertica that corresponds to the Hive database or schema. Then when you query the data within this schema, the HCatalog connector transparently extracts these formats. It formats the data from Hadoop into the tabular data. And then the data within this HCatalog schema appears as if it were native to the HP Vertica.
Right. So that's a great point, Kate. Got a couple of questions on that.
Okay.
One way to think about it is we have introduced in previous HP Vertica versions the idea of an external table. Well, this is sort of goes above and beyond that. It's an external schema. Many tables exist externally. And once we go through the exercise of extracting the data from the external table or schema, we then have that data within HP Vertica, and we can join it. We can create new tables based on that data. Anything that you can do with your normal data, you can do with HCatalog data.
Okay. So does that seem to answer what people were questioning out there? Okay, great. So here is a basic example, or a basic scenario. So if you know the record format of your HDFS file, you can use the Hive QLDDL statements to create a virtual table whose columns look a lot like the HDFS file's record field. And then this layer of extraction basically this level shields the application developers from that frequent churn that people get from the big data. So the file format changes, and you just remap the file to the virtual table. Once you've defined the Vertica external schema pointing to the HCatalog, you can interact with that Hive table just by using regular SQL statements. So the idea here is that you're able to, as we've said, now you've got this external schema, you're connecting in, and it's allowing you to use what you've built in Hive to really start analyze the data using Vertica. There are some limitations working with this. You will not get, as we've said with flex tables, you're not going to get the Vertica performance. You're not going to get the Vertica performance because obviously you've got this extra layer between you, so that you're not going to get the typical Vertica performance. The other thing is that the HCatalog files are really what they are. It's not like you're going to go in and start changing them within Vertica to change. So you cannot create tables, projections in the HCatalog schema. So what it is what it is. So again, you're just making that connector to your Hive. It's not like you're going to suddenly start changing how that's set up. And the HCatalog schema cannot be added to the schema search path. And again, this has to do with sort of some of the stuff that goes on in the background of Vertica. Is how Vertica chooses what table or columns you're referring to. You can't add that schema into the search path. So if you don't have, if for example, your Hive data had something about a customer column and your Vertica data had a customer column, your customer column from Vertica is what's going to be read because so again, you want to have unique column names in your Hive data. And the other thing you want to keep in mind is performance. The HCAT queries are going to add a few seconds per table because it does have to query the HCAT metadata. So again, this has to do with some performance. And one of the other things that partition pruning, you can't take advantage of partition pruning with the HCatalog data, and predicates are not pushed down. So when you're retrieving the records from Hive, basically you're going to retrieve all the records from Hive, and then they're going to be filtered in Vertica. So do keep that in mind, that this does add some performance issues with the HCatalog data. And the other thing to keep in mind is that all columns are going to be read, even if they're not referenced in the query. So again, all of this is to say that there are some limitations to this H catalog. The benefit is that you've already put into the work by building your Hive schemas, and now we're letting you just bring it in and use the analysis that Vertica has and some of its features. But there are some limitations to it.
Right. So building off what Kate's saying and trying to answer a couple of questions at the same time, as I mentioned, it's really like having an external schema. And as Kate mentioned, the external schema doesn't become part of your search path because it would take, basically we'd have to make a connection to Hive every time we did a query to see if those tables existed over there. That's one of the reasons why. The other thing is the schema will periodically get synchronized with Vertica. So there are meta functions to basically get an updated copy of the schema if it is changing on the Hive side.
Okay. So that's pretty much Flex Tables and H Catalog in the short form today. We are definitely open to some questions, but the idea here is that Flex Tables is a new product that's being offered by Vertica. It's allowing you to bring in your semi-structured data directly into Vertica. All Vertica databases, again, are going to start with 1 terabyte. If you want more, it's a separate licensing, and you'll need to talk to your salespeople or your account managers. And then in terms of the H catalog, this is just an added feature allowing you to connect to your Hive systems and your Hadoop, and just making it a little more seamless and easier to work with. So that is what we were talking about today. We'd love to hear some questions or ideas or thoughts from the audience. And we'll give you a few minutes because we realize you need to type things into the question and answer area. And Ron, do you have anything else to add while we're waiting for people to connect on?
Just in terms of performance, there's been some questions about performance, particularly around Flex Tables. You're not going to get the performance that you'd see around when querying a normal Vertica column. And the reason from that is because for every row, we have to go into the map and pull the data out that we're interested in. That's not the case when we have normal compressed encoded Vertica columns. So the idea here is that the data would start its life off as in this raw var binary column, and then over its lifetime it would move from the var binary to a normal Vertica column, which you can then query and get good performance on.
Yeah, so I'm going to just bring us back to that materialization slide where the idea is that you end up with your raw column, and then if you define the columns that you really are going to be using, that's going to give you that Vertica performance that you're looking for. So once you've figured out what makes sense and what makes sense to define as columns, once you get the data in, then you can define those. And that's really, I think that's really the benefit, is that it gives you that opportunity to kind of explore without having to define ahead of time. Right,
exactly. And to answer another question that just came in terms of segmentation, I don't know if we mentioned it in the presentation or we might have sort of glossed over it. There's this special column called map, which we talked about, which gets created automatically for a Flex table. There is actually another column that gets created as well. It's called identity, and this is a incrementing integer which is used for the segmentation expression, so that we can ensure that the rows get segmented across all nodes in the cluster with nice distribution. So it's a normal projection. It's just got these special type of columns. Map and identity. Map is used to hold the raw data, the unstructured data, and identity is used for distributing the data among the cluster.
Okay.
Let's see. Got a question here. Does the 1 terabyte limit apply to H catalog as well? So the answer is no. So your data resides externally in a separate system, so that doesn't come under the Vertica license. question about the examples of what we mean by unstructured data, besides Twitter data. The canonical example is any sort of text-based data is probably a good candidate. So one example is log data from an application that you might write or a web service that you might write. This log data is a perfect example of unstructured data because one, it's sort of semi-structured. There is some structure to it. It's probably every row probably has a date, time, and it's probably got a message and some other metadata that's common to every row. So that's a good example. The other reason that log data is a good example is because it changes over time. And even though you might add every row in your new version of your application might have some user ID information, for example, and that doesn't mean you need to create a separate table to handle this new version of data. You can still use it in the existing Flex table, and just the rows that don't have that username will have a null.
Yeah, and Ron, it's interesting. I was teaching a class actually in December before this. This had just come out, and so I ran through this slide deck or parts of the slide deck just to give people an idea of what's going to happen. And I had some people in the class that are really they're actually tracking network information, so the log files for networks and so forth. And they thought, wow, this is really great because it really does save them the possible loading time and being able to just pull what they need. So people like kind of managing network systems and that sort of thing could really utilize this to get that data in and then just pull those pieces they really needed to analyze out.
A couple of questions on licensing. So in terms of cost, definitely contact your sales representative. But in terms of calculations, we're a column store. So we can easily differentiate between unstructured data in this map column and our normal structured data in our normal Vertica columns. So that's the basis of the calculation between the two.
Okay, so there's some more questions in. We're just getting to read a few of those to see if we can help out some people. We're just give us a few minutes as we get through the questions that are popping up for us.
We've seen several questions come in around whether the presentation will be available. The slides will not be available, but we will post a recording of this webcast on vertica.com/webinars by the end of next week. And that will include the recordings from yesterday and tomorrow as well.
So again,
so Flex tables, the question about how data gets spread to every node in the cluster. Really, it's the same mechanism. We still have buddy projections. So if you load a row into a Flex table and you've got k safe k equals 1, then that row is actually going to reside on two nodes, the two buddies. So your k safe, and it's just a special type of column within a normal projection.
Okay. And the vertica.com/crane for data. Oh, okay. So you can go to vertica.com/crane for your data sheets and buying information. So there is some detail out there already on the web that you can take a look at. Okay, and it doesn't seem like there's any other questions out there. Okay. So I think we're going to just wrap it up at this point, but thank you all for attending. I hope this was helpful in understanding this new product, and you were able to get some information about how we're working with semi-structured data. And I think that's it for today. We will be back tomorrow. Tomorrow is actually going to be a live demo of the Management Console, and we're going to look at some of the new features as well as some of the already existing features to make sure everybody knows what's out there for monitoring. But you're going to get a chance to see how you can look at explain plans and profiles within the new Management Console as well as run the Database Designer. So hopefully you all will come back tomorrow to see that really cool new features that are out there.
Thank you, Kate. And just a reminder, the website for getting the data sheets and buying info for FlexZone is vertica.com/crane. And to view the recordings next week, it's vertica.com/webinars. We look forward to all of you joining us tomorrow. And if any further questions come up, please feel free to post them in our community, which you can find on vertica.com, and we can respond to them in there and get feedback from other Vertica users. We'll talk to you tomorrow.